Hello everyone, this is chapter 7 part 2. In this part we'll learn how to calculate price elasticity of demand and other elasticities using indirect methods of demand estimation. So here's a reminder from chapter 6, or you have probably learned about price elasticity of demand and other elasticities in the past, but if you have not, go ahead and review chapter 6 for me. Okay, price elasticity of demand measures responsiveness or sensitivity of consumers to changes in the price of goods. So we're looking at the impact of a percent change in the price on the percent change in quantity. That's the price elasticity of demand. The formula looks like this. We are going to use capital E, percent change. Remember, Greek capital letter delta is going to be change. Percent change in quantity divided by percent change in price. So percentage change in quantity divided by percent change in price. Price and quantity are inversely related by the law of demand. So if price goes up, quantity demanded goes down. Price goes down, quantity demanded goes up. So because this is a negative inverse relationship, price elasticity of demand will always be a negative number. Okay, the larger the absolute value, so we are going to look at the absolute value of it. The larger the absolute value of E, the more sensitive buyers to a change in the price. Okay, here is the formula, right? Price elasticity of demand, percent change in quantity demanded to a percent divided by the percent change in price. So change in quantity divided by initial quantity. So this portion is basically, if we write it down, final quantity minus initial quantity divided by initial quantity. We can call this change in quantity times 100. That's it. Okay. Same thing for the price. So hundreds will cancel out. So you have delta Q over Q divided by delta P over P. You can actually get this expression, delta Q over Q divided by delta P over P. What we can do, put the expression we have on the numerator right like that and multiply the inverse of this according to multiplication, which is P over delta P, to actually bring that denominator up. Okay, so if you rearrange this, you're going to get delta Q divided by delta P times initial price and quantity levels. Okay, price elasticity of demand can be calculated by multiplying the slope of the demand curve. Oh, nice. That's the B, by the ratio of price divided by the quantity, P times Q. Okay, so interpreting price elasticity of demand, if you find price elasticity of demand that is greater than 1 in absolute value, we call this elastic demand. I'm going to give you actually two examples first. For instance, gasoline. Okay, percent change in quantity divided by percent change in price. Let's say price of gasoline goes up by 80%. Okay, plus 80%. I can only drop my consumption by negative 20%. Okay, so this is going to be 0.025. Okay, in absolute value 0.25. Just keep this number in mind. This is less than 1. Let me give you a different example. For instance, SeaWorld tickets, okay, percent change in quantity, percent change in price. SeaWorld is a amusement park / water park, right? Let's say in this example they increase their prices by 80%. Okay, doesn't matter. Oh, guess what? I am dropping my consumption by 90%. So out of 10 times we used to go over a year as a family, now we're gonna go one time. We're canceling 9 trips. So this is an example of negative. It's going to be 1.11, something like that. Price elasticity of demand will be negative this. In absolute value, this will be greater than 1. So if the price elasticity of demand is positive in absolute value and it's greater than 1, we call this elastic demand. Here's my responses larger. Look, my cut down to the initial percentage change in price, my quantity demanded response is greater than initial increase in price in percentage terms. Here, increase in price yields a decline in quantity demanded of gasoline, but it's smaller than the initial percentage change in price. So elastic segment of demand for which price elasticity of demand in absolute value is greater than 1, such as SeaWorld tickets. Inelastic segment of demand for which price elasticity of demand is less than 1, such as in gasoline. And unitary elastic segment of demand for which price elasticity of demand is exactly equal to 1. Okay, so here's a little table, right? Elastic means price elasticity of demand greater than 1 in absolute value, SeaWorld tickets. Inelastic, price elasticity of demand strictly less than 1, exactly equal to 1, unitary elastic. Elastic demand means subsequent response in absolute value in quantity demanded exceeds the initial change in price. So let's say milk prices, let's pick almond milk. Almond milk prices go up by 20%, price of almond milk plus 20%. I can actually drop my quantity of almond milk demand by 80%. That's what I did actually. Negative. So this is elastic response. Okay, so subsequent response in quantity is greater than the initial change in price and absolute value. Unitary elastic, they're equal. Inelastic demand, just like in gas, response, absolute value of the response and quantity demanded is less than the initial price change. Okay, so let's remember this price elasticity of demand formula again is, right, delta Q over delta P times PQ. And we can actually use my estimated demand function. So this B, I know B is equal to delta Q over delta P. So then it's awesome. I can just substitute B hat here, estimate of that. So price elasticity of demand is going to be the coefficient estimate of the own price, right, times price and quantity ratio. Okay, so that's exactly what we said. Estimated elasticities of demand computed as estimated price elasticity of demand, right? Delta Q over delta P, that was the formula, P divided by Q. This is beta hat. Interesting. How about income elasticity of demand, right? Income elasticity of demand with the same token, change in quantity divided by change in consumer incomes, income divided by quantity. So this delta Q over delta M, boom, C. So estimated income elasticity of demand will be equal to C hat times M over Q. And estimated cross price elasticity will be, right, delta quantity, change in quantity divided by change in price of the related good times price of related good quantity. Okay, so it's going to be, because delta Q over delta PR is equal to D hat times PR over Q. So this is income elasticity of demand, and this is cross price elasticity of demand. Okay. All right, so we also have nonlinear empirical demand specification. So this was a linear specification. And in the linear specification, as you can see, this is really important. As you can see, elasticities are changing numbers depending on the levels of price and quantity, incomes and quantity, price of related goods and quantity. What if I want to find an elasticity that's a constant number? Then I have to use nonlinear empirical demand specification, specifically log linear form. When demand is specified in the log linear form, the demand function can be written as follows, right? And then you take the natural logarithm of this expression, convert to natural logarithms. We covered this in chapter number 4. You can take a look at that. So what you find is this: ln of Q equals ln A plus B ln P, C ln M, D ln PR, and E ln N. Okay, in this case, in this form, elasticities are going to be constant. In elasticity, for instance, price elasticity of demand will be B, income elasticity of demand will be C, cross price elasticity of demand will be D by itself. So keep these in mind. Okay, I will see you in part 3.